What's going on, guys? We have this question right here. It's asking determine the components of force at pin C. So this is the point we have to find. So in this case, I can't find it without breaking it, right? Because we have Cx Cy components. It only happens when we break it. So let's break this component into two parts, and if I draw the two parts, it's going to be something like this. So here we go. This is my B, and here we have C, and we have this pulley right here, and 50 I'll be 50 pounds acting on this side, and we have another 50 pounds this side. Also we have forces at B. It's gonna be Bx, By, and that's all. That's it. And we have the distance here between the pulley and this. It's going to be here. It's going to be 4 feet, and here we have another 4 feet. So let's take the bottom part. This is going to be something like this, and then we have A right here. Here we have C right here, and C is gonna, so when we break, this is gonna have two forces. This is gonna have Cx and Cy. So the only thing we have to remember is, like, whenever we take the direction for the braking part, if we take this direction, we have to take the opposite direction for the other part. So if this is this side, the other side should be like this. This is Cx, and this is gonna be Cy. And then we have also 50 lb. This is pulling this force is acting on this side, so this is gonna be 50 pounds. So let's see what we can do. First of all, also we have Ax, Ay right here. Ax, Ay. First of all, if I see this one, we have two unknown here, two unknown here, and known here. So if I can't take x component or y component because two unknown. If I take movement around this one, what happens? So if I take movement around this one, it seems like I can solve for Cy. Let's see this one. If I take movement around this one, I have Cx unknown, Cy unknown, and so it's better to take the moment around this one because we can find the Cy directly. So let's take this one. I am taking in the BC, the moment around B. So the question is asking to find the CXCY, so we are interested in that. That's why I'm taking B. Moment around B. If I take moment around B, the total moment is 0 in statics, and if I take counterclockwise positive and solve for this one, I will get 50 pounds pulling this object down, and it's in 4 feet distance. So it's going to be 4 times 50, and it's clockwise, therefore it's going to be negative. Then we have 50 pounds pulling this object. It's also pushing this object clockwise, but it's how many? 1 point, it says 2 feet height, because 1.5 here is 0.5 here, so it's going to be 2 feet height. Therefore this is going to be negative 2 times 50. Then we have Cy is pulling this object down. It's also clockwise, therefore minus Cy times the total distance is 8 feet. So it's going to be multiplied by 8 and equal to 0. And if I solve for Cy, it comes out to be 34.41 pounds. But by looking this equation, you can say this is going to be a negative number. Therefore, we know that the direction we picked is wrong. It's going to be acting upside. So let's keep this way. So if you mention negative, it's automatically opposite direction. So let's keep this way, cy, and then we have to find cx. To find cx, now I can, so if I find this one, okay, so let's move to this one. So if this is negative 34.41, then here it's going to be same thing, negative 34.41 pounds, right? So if this is negative 34.41, then what we have to do is we have to take the moment. If I take a moment around a, I will get rid of these two and I can find cx directly. So let's do that. So in the AC, if I take moment around a equal to 0 in statics, if I take counterclockwise positive and solve for this one, I will get 50 pounds pulling this object up, and it's in 4 feet distance, and it's acting clockwise. It's going to be positive 50 times 4. Then we have cx pushing this object counterclockwise, therefore it's going to be positive, plus cx times, we have to know the height is 6 feet given, so this is going to be times 6. Then we have cy pushing this object counterclockwise, we have to know this distance is 8 feet, so it's going to be plus 8 times, we know the cy value already, it's going to be minus 34.41, and if I equal to 0, and if I solve this system, I will get cx is equal to negative 16.7 pounds. So negative represents that the direction is opposite. So what's going to happen is in both cases the direction is going to be opposite to whatever we took. So this is the final answer. I hope you guys like this video. See you next time.